In this tutorial, we'll discuss in detail how to properly format the data in a string, and we'll also look at the embedded properties of data event. Let's look at a section of a third-party device protocol so we know what we will be trying to accomplish with our code. The one we'll look at is for the Tascam DVD player. The protocol gives us the communication specifications. In this case, our device requires communication via RS-232 with a baud rate of 9600, a parity of none, a data or character length of 8, and a stop bit of 1. Notice that the protocol tells you how to form the structure of the string that you will use to communicate with the device. Since this is a DVD player, let's look at what it would take for us to tell this DVD player to play. Notice when we look at the protocol for our DVD player, we see two different types of data. The first is an ASCII string. ASCII strings are a character encoding scheme that is used in computers. It is based on the English alphabet. The characters encoded are numbers 0 to 9, lowercase letters A to Z, uppercase letters A to Z, basic punctuation symbols, and a space. Essentially, most of the keys on your computer keyboard. The second is called hexadecimal. Hexadecimal, or hex, is a numeric system with a base of 16. It uses 16 distinct symbols. The symbols are 0 to 9 to represent the values 0 to 9, and A, B, C, D, E, and F to represent values 10 to 15. Several different notations are used to represent hexadecimal in computing languages. A prefix, 0x, is quite common, or some authors denote hexadecimal values using a suffix or subscript. In this protocol, the manufacturer has chosen to use lowercase h to represent hexadecimal. In NetLinks, we represent hexadecimal using a $sign before the value. If we examine an ASCII chart, we can see how the ASCII, the hexadecimal, and the decimal numbers are used interchangeably. Because the keyboard does not have a happy face or a heart, we are required to use the hexadecimal equivalent for the first and last bytes of the data. When executed, this will send a string through the NetLinks device to the DVD player and request the DVD player to play the loaded DVD. Notice that a string is put together with double quotes. We call this a string expression, and the single quotes, we call this string literal. A string expression combines two or more types of data into a single string. It can contain any ASCII character, decimal, or hex value, variables, string literals, and arrays. String literals can only enclose values ranging from decimal 32 to decimal 126, which represents an ASCII character. A string literal is a constant value that is set at compile time. Once loaded into the central controller, this string cannot be changed. The difference between a string literal and a string expression is that the string expression is built at runtime instead of compile time. As a string expression is processed, each member of the expression is evaluated from left to right. The result is a complete string. Communication is a two-way conversation, and this is no different in the digital world. We will need to know how to receive data as well as send it. NetLinks is able to process data received from a device by a data event in real time using the string handler. We've already built a few data events, but up until this point, the only handler we've used is the online handler. When data is received, it enters the message queue and triggers a data event. The data is placed within a memory location we call a device buffer and can then be used in the data event string handler. The evaluation of the data should be done immediately upon receipt of the chunk of data. The actual string that is received by the message queue can be evaluated using the data.text embedded property within the data event. The data.text is automatically created when the string handler is added to the programming and is associated with the device specified in the data event. The data.text is of a fixed data size, and the data is only present when the device sends a chunk of data. When the data event is over, the data in the data.text is no longer available. Let's now learn about parsing the incoming strings to understand what the device is telling us.